Your essential question for today is, how do we recognize, analyze, and graph ellipses? We're still going to be talking about vertices and co-vertices and foci and major and minor axes, but what if the graph has been moved? Just a quick refresher for this is that, remember that the foci lie on the major axis. So just remember that. Whatever the major axis is, that's where your foci and your vertices lie. The formula that we use to find my foci is the formula c squared equals a squared minus b squared. So just a quick refresher, it says question 1, what is the equation for an ellipse in standard form always equal to? The answer to that is your standard form is always 1. Question 2, it says the vertices are always on the major axis. So the vertices are always on the major axis. Question number 3, the co-vertices are always on the minor axis. So the co-vertices are always on the minor axis. And then question 4, the foci, just like the vertices, the foci are always on the major axis. So that would be my 4 questions for that. So let's take a look at an example right quick, and keep in mind, standard form for an ellipse is always set equal to 1. So if I give you this scenario right here, this is an example of an ellipse, but it is not in standard form. How do I know that this is not in standard form? What does it have to be equal to in order to be in standard form? It's got to be equal to 1. It's not equal to 1. So this is not a standard form. This is what we call general form. Now, here's the thing, though. I can automatically tell that this is an ellipse because of 2 things. First of all, I notice that my x squared and my y squared, both of those are squared. You see the x squared and the y squared. So that lets me know that it's a circle or an ellipse. The reason why I know it's an ellipse and not a circle is because the coefficients in front of the x squared and the y squared are different. I've got an x squared, the understood number in front of that is a 1. I've got a y squared, the understood number in front of that is a 4. Because those coefficients are different, that's how I know that it is an ellipse and not a circle. So here's what I'm going to do. So here's what I've got. Here's the problem, guys. The problem is this is not in standard form. So I have no idea where the center is, but I'm going to show you how you find it. It's almost similar to a circle. In that aspect, what we're going to do is we're going to group and move. Remember that when we did that with circles? We're going to group and move. So that's my first step. I'm going to group and move. So what I mean by that is group your x's together. So I've got x squared minus 4x. And then group your y's together, so 4y squared plus 32y, and then move that number over to the other side. So just group and move. So that's no different than what we did for a circle. In fact, what I love about conics is the fact that once you really know how to do one of them, it applies to all of them. So it's kind of like the same steps over and over again. All right, here's what's different, though. The reason why it's different is because on a circle, both of the numbers were the same. Well, if you notice I underlined that 4, that's my problem. I see that 4 right there. So what I'm going to do is I'm going to factor that 4 out. So what I mean by that is, here's what I'm going to have. I'm going to have x squared minus 4x. See, there's nothing here but understood 1, so you don't have to worry about factoring anything out. But go ahead and leave a space right there. But here I see that positive 4, so I'm going to take out that 4. I'm going to factor out that 4. Well, when I do that, what gets left behind is y squared, and then just make sure you do 32 divided by 4, so that would be 8. So 8y, and then leave a space. That's the only thing that's different between a circle and ellipse, is the fact that you might have to divide by that number that's right there. And so what I'm going to do now is, like with the circle, I'm going to complete the square. So let's complete the square. Half of negative 4 is negative 2, but then square that. So negative 2 times negative 2 is a positive 4. And just remember, whatever you do to one side, make sure you do it to the other side. So I put plus 4 over here as well. All right, now we're going to complete the square in this part right here. So half of 8 is 4, and then 4 squared is 16. But here's the trick, guys, because you have to be very careful. You technically didn't just add 16. Do you remember how you factored out that 4? Well, that 4 is still out there, so it's really 4 times 16. See that 4 times that 16? Well, 4 times 16 is 64. So I really didn't add 16. I technically added 64. So that's the trick right there. Make sure you don't just add 16. Whatever you factored out, multiply that back in, and that's what you're going to add on this side. Well, once you've done that, it's really kind of like a circle now. We're going to rewrite this. X squared minus 4x plus 4. Half of negative 4 is negative 2. So you're going to have x minus 2 squared plus 4, and then rewrite this, y squared plus 8y plus 16. So half of 8 is y plus 4. And then just use your calculator over here, negative 52 plus 4 plus 64, and that gives me 16. And so then that's how we've got it almost in standard form, but here's the only difference. It's an ellipse. You know, an ellipse has to be set equal to what? 1. This is set equal to 16. How could I force this to be equal to 1? Not really minus, but divide everything by that last number. Because see over here, 16 divided by 16 is going to give me 1. And then we're just going to clean this up over here. So I can't reduce anything, so this still stays x minus 2 squared over 16. But you see the 4 over 16 that's right here? How many times does 4 go into 16? 4 times, so that leaves me y plus 4 squared over 4. And there's my standard form for my ellipse. And so why don't we take a second and let's graph this one. See, let's talk about how this one's different. So for this one, notice that my center is going to be at positive 2, negative 4. That would be my center. What you got? All right, so my center for this ellipse is going to be at positive 2, negative 4. So remember, you got to think opposite. So my center is at positive 2, negative 4. And so then we can graph that now. So I'm just going to graph that center on this graph. So 2, negative 4. So I'm going to go over to 2, down 4. 1, 2, 3, 4. I'm going to run out of room, guys, so I'm going to have to go down a little bit. So let me rewrite it. So there's 2, negative 4. So there's my center right there. And then the x number below that is 16. So for the x-axis, the square root of 16 is 4. So from the center, I'm going to go left and right 4. So 1, 2, 3, 4. 1, 2, 3, 4. So go left and right 4. The y-axis, see the number below that is 4. So the square root of 4 is 2. So I'm going to go up and down 2. And so right there, 1, 2. So there would be my ellipse for this situation. So remember, if the center is given like that, it's always the opposite. So 2, negative 4, and then my square root of 16 is 4, so left and right 4, and then the y is 4, so square root of 4 is 2, so up or down 2. So it's those same steps over and over again. All right, let's take a look at a second example. So for this one, it's the same process over and over again. So it's the same steps over and over again. So for this one, I've got 4x squared plus y squared minus 80x minus 18y plus 381 is equal to 0. I know that this is an ellipse because it's x squared and y squared, but the coefficients are different. This is a 4 and this is a 1. And so what I'm going to do first is I'm going to group and I'm going to move. So I'm going to group my 4x squared minus 80x plus 1y squared minus 18y, and then I'm going to move this 381 over to the other side, so that gives me negative 381. And so then this is my first step, group and move. And then if I need to factor, I'm going to go ahead and factor. And I notice, see right here, that 4 that's in front, I need to factor that 4 out. So that's what I'm going to do with that 4 right there. So I'm basically going to divide by 4. So the 4 is going to come out, factor that out. That'll leave me x squared. And then negative 80 divided by 4 is going to be a negative 20, and then leave a space. And then plus y squared minus 18y, and then leave a space after that also. So notice that I didn't have to factor anything out for this y squared. I just simply rewrote my little space right there. So if there's a number in front, then you have to factor it out, but there wasn't in that case. And so now let's complete the square. So half of negative 20 is negative 10. You square that, you get 100. But be very careful. You don't add 100 here, because in reality, you took out that 4. Yeah, 100 times 4. So you're really going to add 400. So 100 times 4. So you're really going to add 400. And then right here, half of negative 18 is 9. 9 squared is 81. So I'm just going to put plus 81 to both sides. And so now you can just simply rewrite this. So I'm going to have a 4 on the outside. This, x squared minus 10x plus 100. So that's going to rewrite into x minus 10. And then this right here is going to rewrite into y. Half of negative 18 is negative 9. So I get 4 x minus 10 squared plus y minus 9 squared equals, and then negative 381 plus 400 plus 81, that gives me 100. So that's really great. The problem with this, though, is if I want to standard form, it's got to be set equal to 1. So how am I going to fix this so it's set equal to 1 instead of, divide everything by 100. So guys, once you know how to do one of these, they're pretty much straightforward. So this reduces, and here's my final answer. 4 goes into 100 25 times. So I'll have x minus 10 squared over 25 plus, nothing to simplify here, so y minus 9 squared over 100 is equal to 1. And that would be my answer for this. Now, if I wanted to be more precise, my center would be at positive 10, positive 9. I would go left and right 5, and I would go up and down 10. Because remember, it's always the square root. So the square root of 25 is 5. The square root of 100 is 10. And so that would be what I would do for that problem. So simply just, it's the same steps. Group and move, factor out if you need to, rewrite, and then divide by that last number. It's the same steps each time. All right, take a second and give this one a try. And I'm going to... All right, so with this problem, what's your first step when you see this on a test? And it's an ellipse. Group and move. So hopefully you rewrote this as 9x squared minus 180x plus 4y squared minus 16y equals negative 340. So that's your first step, group and move. Your next step is factor. But you see what I did here? I made you have to factor both of them. So out of the x, factor a 9, and hopefully y'all got 20 for that. Leave a space. For the y, make sure you pulled out that 4, and this is negative 4, so leave a space. So make sure it looks like that. You took out a 9, you took out a 4, and so that would be my factoring out. So now let's complete the square. Half of 20 is 10, 10 squared is 100, but you're not going to add 100 here, you're actually going to add 900. Half of 4 is 2, 2 squared is 4, but you're not really going to add 4, you're going to add 16. Okay? All right, and so now, let's rewrite this. I'm going to have 9x minus 10 squared plus 4y minus 2 squared. And then what I'm going to do here is I'm just going to say negative 340 plus 900 plus 16, and that gives me 576. Okay, so 576. And now to finish it off, divide everything by 576. So divide everything by 576, so divide this by 576, divide this by 576, and divide this by 576. And so now your final answer, though, simplify this, 576 divided by 9 is 64. So this would be x minus 10 squared over 64. Yeah, 64. Okay. And then plus, y minus 2 squared. What's that, 144? Yes. Okay, so over 144 equals to 1. And that would be the equation of the